1124, Module 12, Submodule 3, Wireless LAN Operation. This section goes into the different types of access points and the modes that your access points can be in. First slide gets into, there's three specific topology modes: ad hoc, infrastructure, and tethering. Very straightforward stuff. Hey, I don't have an access point. I want to send something directly from one device to another. Apple does something like this, where you can just like shoot files back and forth. I don't even know what it's called, but it'd be an example of ad hoc mode, where there's no access point. In most cases, in almost all cases, you're going to have an access point, and if you have an access point, it's known as infrastructure mode. And then the third mode that just kind of popped in is the tethering mode, which I think everyone's familiar with, where you can have a device and you can just kind of piggyback off of that device. You can have it create its own network and be its own access point as it uses another antenna to go on and get out to the internet. So you'll see that with smartphones a lot. It's a really cool, I use it all the time just because I never feel safe connecting to anyone's Wi-Fi. So if you feel that way too, you're probably using tethering a lot. And then you run your VPN through it. All right. The next piece, also very simple, very easy to explain. The BSS and the ESS, the basic service set versus the extended service set. Look at the diagrams. Basic service set, one access point. Extended service set, more than one access point. Okay, next slide. Frame structure. As we mentioned before, there's a lot of stuff that is going to need to be sorted out when you're wirelessly sending stuff across from one device to another. Not only do you need the basic things that you would normally have, like the source and destination MAC addresses and the type field, you're also going to need the SSID value, the name of the wireless network. You're going to need the channel you're using. You're going to need to know if you're authenticating it all and need to use a password in order to gain access to the network. You're going to need to associate with the network. You need to know what the signal strength is. There's all these other things that go into the 802.11 frame structure that have to be sorted out in order for you to make a communication wirelessly as opposed to wired. And it has to be compatible with the wired system so that you can take everything that you needed for the wireless and then sweep it away and then make a wired frame header and send it on to wherever it needs to go. So there's a communication path there. This slide just talks about the idea of how it is that our wireless devices are going to communicate. I don't want to get too deep into standard Ethernet, but when we see CSMA in any case, there's always CSMA CA and there's CSMA CD, right? So wirelessly, we use CSMA CA. CSMA stands for Carrier Sense Multiple Access. Carrier Sense Multiple Access. So Carrier Sense basically says this. The first thing that we're going to do when we're going to make a communication from one device to another is we're going to check to see if our channel is clear to go ahead and send something. Are we already trying to send something to someone else? It's analogous to, and I know the younger people aren't going to know this, but the older people will. Carrier Sense is exactly the same thing as when we used to all have home phones and we had lots of extensions of phones. And you wanted to see if you could make a phone call. The first thing you did is you picked up the phone and then you checked to see if you heard a dial tone. And if you heard a dial tone, that was your Carrier Sense that said, it's okay for you to dial a number now. It's going to work. You're connected to the system. If you picked up the phone and your sister was on the phone, which is 90% of the time, you wouldn't be able to make a phone call because the phone was already being in use. So that's a good example of like what Carrier Sense is. All you younger people that never had home phones, just imagine what that was like, okay? And hopefully it'll make sense. Second thing is multiple access. Multi-access just means this. I've got one network card. I got one card, and that card can communicate with a lot of other devices. So when we think about the idea of a LAN is a multi-access topology. I've got 10 or 20 computers. They all have one card, and they all have the ability to connect with each other just on that one card. I don't need a separate card. If I have 10 computers in a room, each computer doesn't need 9 cards, one to connect to each one of the other devices. That's crazy. That system's not going to work. CSMA says this. We can check our line. We have a single line out. If it's not being used, we can use it. Multi-access says this. There's something in the frame header that we're going to use, MAC addresses, that are going to be utilized so that we can send stuff to many different things across the same channel, and it'll get to the device that I want it to get to. I don't have to build a separate channel for each device that I want to connect to. So CSMA in a nutshell, that piece is done. Great. And that is true of wired or wireless LANs. They both work in CSMA. Now, the difference between the wired and the wireless is going to be collision detection versus collision access. Now, in this case, we're going to talk about collision avoidance. We're going to talk about collision avoidance. Collision avoidance just says this. In a wireless solution, most of the time, your wireless network is going to have an access point that's going to be like your controlling device that tells devices when they can and cannot send information. So here's a basic example of what happens in a wireless LAN solution. Access point is passing out radio waves and sends out a message to all the antennas that are associated with it. Excuse me, by the way, if you're interested in sending data anyplace, I'm going to have a period of contention over the next X number of seconds. So if you're interested, please send me a message. And then from that, the access point is going to pick which device it wants to allow to communicate. And it'll send a message back out to everyone. Thank you for participating. I've selected device, MAC address, whatever. If you all could be so kind, you other devices, if you're within earshot of this, stop sending stuff to me and just don't do anything for the next X number of milliseconds. Unless your device X that's been selected to send their signal. And over that time space, that device will be able to communicate to the access point. The access point will then pass that data to wherever it needs to go. That time will expire. There'll be a very short period of quiet, and then the contention period starts again, and then the access point will decide on another device, and that device will be allowed to send while the other devices stand down, and back and forth it goes so that all of the devices are truly actually not sending at the exact same time, but it happens so quickly that each device will be able to communicate, and the end user won't even know that it's not a consistent stream. It's actually being interlaced with other devices getting their signal at the same time. So that's a little bit about collision avoidance. So it's a managed solution between the devices. All right, good. Next slide. Wireless client and access point association. Just look at the 3 bullet points on here and know this order. That's really all I really want you to know here. Discover a wireless access point. So there's a discovery period, right? And you have to figure out if you're going to, is this active or passive? Who's got the SSID? Do we want to connect to that? I'm not sure. But we've got to find out what wireless network you want to connect to. That's the name of the wireless network. So there's a discovery piece. Once you're discovered, you can authenticate. Is there a password that needs to be passed back and forth? And then there's an association point where everything comes together and you are now tied to that particular access point, and you can send data across there. This just shows some of the association values that you're going to have to identify. The SSID, the name of the network, the password if necessary. What mode are we using? Hey, this is 802.11g. No, I don't want to connect it that. I want to connect it 802.11ac. That's way faster. Well, the access point only goes to G or N or whatever. So security mode. What type of security are we going to utilize? Is this going to be a shared secret? Is this AAA services? And then finally, hey, what channel are we using? There's in 2.4 gigahertz space, there's 11 usable channels. What channels should we utilize in order to make this communication so that there's room for other wireless devices in that 2.4 gigahertz space to also communicate on other channels, and there won't be any overlap between those. There's also 5 gigahertz space, and it has many channels as well. So keep that in mind. And this just talks about the passive and active mode of the SSID being passed or not. So no big deal there. That's this piece.